Hello everyone, my name is Lindsay Felker. I'm a registered nurse with 13 years of experience specializing in women's health. As a labor and delivery nurse, I've always been fascinated by the intricate process that begins life, fertilization. Today, we're diving into this topic in detail, exploring what happens after an egg and sperm meet, and how this miraculous journey leads to the establishment of pregnancy. Before fertilization occurs, the human body undergoes a process called gametogenesis, which is the creation of gametes, the ova in females and sperm in males. This process is driven by a type of cell division called meiosis. Unlike mitosis, which creates two identical daughter cells, meiosis produces 4 cells, each with half the chromosomes of the parent cell. These haploid cells carry 23 chromosomes compared to the 46 chromosomes in diploid cells. For females, this process is known as oogenesis. A female is born with 1 to 2 million oocytes in her ovaries. However, during her reproductive years, only about 400 to 500 ovae are released. The rest are reabsorbed. In males, this process is called spermatogenesis, which doesn't begin until puberty. Each spermatogonium gives rise to 4 spermatozoa. Let's compare the differences. During oogenesis, only 1 ovum and 3 polar bodies are formed, with the polar bodies disintegrating. In spermatogenesis, each division produces 4 functional sperm cells. Each month, in the absence of pregnancy, lactation, or hormonal suppression, 1 ovum is released during ovulation. This process begins with a primary oocyte, which has 46 chromosomes. In meiosis 1, the primary oocyte divides into a secondary oocyte and a polar body, each with 23 chromosomes. The secondary oocyte only completes meiosis 2 if fertilization occurs, ensuring the ovum retains most of the cytoplasm necessary for early embryonic development. During her reproductive lifespan, a woman typically ovulates about 400 times. The remaining oocytes gradually decline until menopause, marking the end of her reproductive years. Now let's shift to the male contribution. Spermatogenesis is a highly efficient process that produces millions of sperm every day. For successful fertilization, a sperm cell must travel through the cervix, uterus, and into the fallopian tube, propelled by its tail. Of the millions of sperm released during ejaculation, only about 1 million make it to the oocyte, and a much smaller number, usually just a few dozen, reach the zona pellucida, the outer layer of the egg. Interestingly, research suggests that the oocyte may play an active role in selecting the sperm it allows to penetrate. Only 1 sperm ultimately fertilizes the egg, triggering the cortical reaction, which blocks additional sperm from entering. Fertilization typically occurs in the fallopian tube, where the sperm and egg meet. The sperm must penetrate 2 layers surrounding the egg, the corona radiata and the zona pellucida. Enzymes in the sperm's acrosome help it dissolve these protective layers. Once the sperm penetrates the egg's plasma membrane, the egg completes meiosis 2 and ejects half of its chromosomes in a polar body. The sperm's 23 chromosomes unite with the egg's 23 chromosomes, forming a diploid zygote with 46 chromosomes. At this point, the genetic sex of the zygote is determined. If the sperm carries an X chromosome, the zygote will be female, XX. If the sperm carries a Y chromosome, the zygote will be male, XY. From this single-celled zygote, a rapid and highly coordinated process of cell division begins. This is known as cleavage. Within 72 hours of fertilization, the zygote divides into 12 to 16 cells, forming a morula. Around day 4, the morula enters the uterus and begins to accumulate fluid, transforming into a blastocyst. The blastocyst contains 2 distinct cell types, the inner cell mass, which will become the embryo, and the trophoblast, which will develop into the placenta, the organ responsible for nutrient exchange between mother and baby. By day 6 or 7, the blastocyst begins the process of implantation into the uterine lining, or endometrium. The trophoblast releases enzymes that allow the blastocyst to adhere to and penetrate the endometrial surface. The endometrial cells at the implantation site become hypertrophied, and blood flow between the trophoblast and the spiral arteries of the endometrium is established. At this stage, the trophoblast also begins secreting human chorionic gonadotropin, or HCG, a hormone that maintains the corpus luteum and its production of progesterone. This ensures the uterine lining remains hospitable to the developing embryo. HCG levels rise rapidly in the early weeks of pregnancy and are the basis for pregnancy tests. It's important to note that not all fertilized eggs result in viable pregnancies. Ectopic pregnancies occur when the fertilized egg implants outside the uterus, often in the fallopian tube. These pregnancies are not viable and can pose serious health risks to the mother. Chromosomal abnormalities in the zygote can also lead to early pregnancy loss. In just a few days, the journey from a single sperm and egg to a developing blastocyst represents one of the most complex and fascinating processes in biology. Understanding this process not only deepens our appreciation for the beginning of life, but also underscores the delicate balance required for a healthy pregnancy. Thank you for joining me on this exploration of fertilization and early pregnancy. As you continue your studies, I encourage you to marvel at the intricate steps that transform two microscopic cells into a new human life. Super! This video contains real medical imagery for educational purposes.